In this video for section 6.1, we're going to talk about something called the normal distribution. We used the binomial distribution earlier, and we would use that if we have a discrete random variable, which, as you might remember, means that it's something that can be counted. If it's something that is measured, or a continuous random variable, we would use the normal distribution. The normal distribution is bell-shaped and symmetric, and you might remember it from when we talked about the empirical rule earlier. So for the normal distribution, the mean and median are approximately the same, and as you remember, that's going to be the case when you have a symmetric distribution. The probability of something being greater than the mean is 50%, and the probability of something being less than the mean is also 50%. With the binomial distribution, we had problems where we were asked to calculate the probability of getting exactly one particular number. And this would be the case for other discrete distributions as well, which we didn't talk about any other ones, but they are in the textbook. If you have a continuous distribution, like the normal distribution, the probability of being exactly any particular number is 0. And so we won't have problems where we're asked to calculate the value of getting exactly one number. There's something called the standard normal distribution, which sounds a little redundant, but that means that you have the normal distribution that has a mean of 0 and a standard deviation of 1. And when we did the empirical rule problems earlier, those were based on the standard normal distribution. Now, we're going to use Minitab to calculate these probability values. There are formulas and there are tables described in the textbook. Don't use those, use Minitab, it's much easier. So when we did this with binomial distribution problems, we were given the number of trials and probability. When we have a normal distribution problem, we are going to be given the mean and standard deviation. So let's look at example 6.1. Airport managers have found that the time needed to get passengers loaded onto an airplane is normally distributed with a mean equal to 15 minutes and a standard deviation equal to 3.5 minutes. Find the probability that loading passengers will take 22 minutes or more. So we're going to go to Minitab. And I'm going to go to probability, distribution plot, and display probability, just like we did for binomial probabilities. Now I can leave this on normal because that's what we're using, and I'm going to enter the mean and standard deviation. The mean in this case was 15 and the standard deviation was 3.5. Then I'm going to choose specified x value, and what I want to know is the probability that it will take 22 minutes or more. So since it's 22 or more, that's going to be a right tail because numbers more than 22 are going to be on the right, and my x value would be 22. Unlike the binomial distribution, with the normal distribution, you don't have to worry about increasing or decreasing the number by 1. So 22 minutes or more, or if it was more than 22 minutes, I would enter 22 either way. Then I click OK, and I get the graph. Now, just like with binomial, what I'm going to look for is the probability above the red shaded area. So in this case, my answer would be 0.0228. If I round to 4 decimal places. Now the second part of the question says 95% of flights will be loaded in less than what time? Now this is a little bit different because now I'm not trying to find the probability. What I'm being given is the probability. So this 95% is a probability of 0.95. And they want to know 95% of the flights will be loaded in less than what time? That means that what I'm looking for is the x value. In the problem above, what I'm being given is the x value, and I'm looking for the probability. So I'm going to go back to Minitab here, and I'm going to enter the same information for mean and standard deviation, which were 15 and 3.5. Now this time, I'm going to leave it on a specified probability. And I want to know 95% of flights will be loaded in less than what time? So this is going to be a left tail because less than is on the left. And I'm going to change my probability to 0.95. Click OK. Now this time, the 0.95 is what appears above the red shaded area. To find my answer, I look on the x-axis of the graph. And I can see here that my answer is going to be 20.757. So identify where the problem wants you to round and enter your answer. So in this case, if it was to the nearest tenth, it would be 20.8. And that is time in minutes.